Hello all, in this video we are going to learning about mathematical analysis of recursive algorithm, general plan for analyzing the time efficiency of recursive algorithm. In the first step we decide on a parameter indicating an input size n. Next, identify the algorithm's basic operation. In the third condition, check whether number of time basic operation is executed can vary on different input of same size. If it is vary, then find the best case, worst case and average case efficiencies. Must investigate it separately. Fourth step, set up recurrence relation with an appropriate initial condition for the number of time the basic operation is executed. In the fifth step, solve the recurrence or at least ascertain the order of growth of its solution. Let's analyze this mathematical analysis of recursive algorithm by some examples. The first problem is factorial function. Compute n factorial recursively. Input is a non-negative integer n. Output is the value of n factorial. The algorithm is if n is 0 then return 1, else return factorial of n minus 1 into n. Okay, let's analyze this algorithm using an example. Consider if n equal to 0 then the factorial of 0 is 1. Okay, it returns 1, else return. Consider if it is n equal to 2, that is 2 factor. If n equal to 1, next if compare if n equal to 0, no, false. Next go to else condition. 1 factorial f of 1 minus 1, that is 0 into n. F of 0 into n, that is 1 factor. F of 0 means 1, 1 into 1, that is 1. Next substitute n is 2. Again if n is 2, no. Going to else condition, return factorial of n minus 1, that is 2 minus 1, 1 into 2, that is f of 1 is 1 into 2, that is 2. Okay, next substitute n equal to 3. Again return factorial of n minus 1, that is 3 minus 1 is 2 into n, that is 3. 2 into 3, 6. Like this way this algorithm continues. You can see if we want to find the 3 factorial, then we have to know f of 2. If we have to know the 4 factorial, then we have to know the f of 3. That is the backward substitution we are doing. Okay, this is called recursive function. We call the recursive functions again and again. Okay, let mathematical analysis this. The input size is nothing but an non-negative integer n, that is a given number n. Next, the basic operation. In the innermost loop we performing multiplication, hence consider multiplication as a basic operation. Third step is no best, worst or average case. Basic operation not vary on different input of same size, hence there is no best, worst or average case. The fourth step is let m of n denotes the number of multiplication. M of n becomes m of n minus 1 plus 1. Okay, here what is this 1? 1 stand for to multiply the factorial n minus 1 by 1. This condition we taken as 1. And what is m of n minus 1? To compute factorial n minus 1 and set the initial condition that is 0. In the fifth step, solve the recurrence solving problem as we seen in the analysis of algorithm, that is backward substitution. Also solve this by backward substitution. Okay, we have the formula m of n is m of n minus 1 plus 1. Same thing. Next we have to find what m of n minus 1. Substitute wherever n, substitute n minus 1, that is m of n minus 1 minus 1 plus 1, that is m of n minus 2 plus 1. Okay, we substitute m of n minus 1 by m of n minus 2 plus 1 plus 1. Okay, that is nothing but 1 plus 1 is 2. Next we have to find what is m of n minus 2. Again wherever n is present, substitute n minus 2, n minus 2. We got m of n minus 2 as m of n minus 3 plus 1. substitute where m of n minus 2 by m of n minus 3 plus 1 plus 2. Again it becomes m of n minus 3 plus 3. Then again what is m of n minus 3? Substitute n by n minus 3. n minus 3 minus 3 plus 1, that is m of n minus 4 plus 1. m of n minus 4 plus 1. So on this backward substitution goes on. Okay. In the ith recursion, what we got? M of n minus I plus I and plus I. Here consider this 1, 2, 3, 4. It incrementing, right? Consider as a I. Here also it increment by 1. I is same. N minus I plus I. When I becomes n, consider when I becomes n, then this equation become m of n minus n plus n. We know that the initial condition is 0. M of 0 becomes m of n minus n is m of 0 plus n. m of 0 is 0 plus n, that equal to n. Hence m of n is n, belongs to order of growth theta of n. The second problem is Tower of Hanoi. In this problem, the input is the disk, n number of disk and 3 pegs, and output is moving source to destination and large disk at bottom and small disk at top. We can see this input and output in the example. Okay. The algorithm goes like Tower of Hanoi, disk, source, destination and auxiliary. If disk equal to 1, move disk from source to destination. Else Tower of Hanoi, disk minus 1, source, auxiliary, destination. Move disk from source to destination. Tower of Hanoi, disk minus 1, auxiliary, destination, source. Okay, let's see this algorithm by an example. Consider if n is 1, that is disk equal to 1, then move disk from source to destination. Consider 3 number of pegs and here disk is 1. What we have to do? Move disk from source to destination. This is the source peg and this is the intermediate or auxiliary peg and this is the destination peg. Just if it is 1 peg, just move a disk from source to destination. Okay. Else consider n equal to 2. Then what we have to do? Tower of Hanoi, disk minus 1, that is 2 minus 1, source, auxiliary, destination. We have to move n minus 1, that is 2 minus 1, first disk from source to auxiliary by destination. Consider we have 2 disks. In the first step we have to move 2 minus 1, that is first disk from source to auxiliary using destination. Consider 2 disk. We have to move this first disk. Okay, first disk from this source to auxiliary we moved. Okay, next move disk from source to destination. What left? This big disk is left. Move this to destination. In the next step what we have to do? Tower of Hanoi, again disk minus 1, auxiliary, destination, source. We have to move which disk? First disk to auxiliary to destination, that is auxiliary to destination with the help of source. Okay. How many moves we did to moving 2 disk from source to destination? And we can see the big disk at the bottom and the smaller disk at the top. To find the number of steps we did, use 2n minus 1 formula. In this we used 2 to the power 2 minus 1, that is 4 minus 1. We take 3 steps to move a disk from source to destination. Like the same way, by seeing the algorithm, consider if there is n number of disk, then we have to move first disk minus 1, 3 minus 1 disk, that is second disk, 3 minus one disk from source to auxiliary by the destination. Like this, we have in the first we have to move first peg from source to destination. Next we move second disk from source to auxiliary, and again first disk from destination to auxiliary, again third disk from source to destination, again first disk from auxiliary to source, again second disk from auxiliary to destination, again first disk from source to destination. Like the same way write the drawing if you don't understand the step. And how many number of steps we taken is 2 to the power 3 minus 1, that is 8 minus 1 equal to 7. Okay, this is the simple problem, and like playing a game to moving a disk from one peg to other peg. Okay, next mathematical analysis of Tower of Hanoi. In the initial step, the input size is a given number of disk. The basic operation what we are doing, that is moving a disk from source to destination. We don't need best case, worst case, average case, because basic operation not vary when the input size of same size. Let m of n denote number of moving disk from one peg to another peg. M of n minus 1 plus 1 plus m of n minus 1 for all n greater than equal to 1. Initial condition what we take, n equal to 1 is the initial condition. Okay, here what is m of n minus 1? Moving n minus 1 disk from source to auxiliary. What is this one? To move a longest disk from source to destination. What is this m of n minus 1? That is move a n minus 1 disk from auxiliary to source. The fifth step is solve the recurrence using backward substitution method. M of n, we have m of n minus 1 plus 1, m of n minus 1, that is nothing but 2 times m of n minus 1 plus 1. We have to do what? Backward substitution. We need m of n minus 1, wherever n is present replace by n minus 1, replace here also by n minus 1. This we got. Substitute here m of n minus 1, to take common now, 2 times m of n minus 2 plus 1 plus 1. Here 2 into 1 2, 2 plus 1, 2 into 1 2 plus 1, that is 3, 2 square m of n minus 2 plus 3. Again what is m of n minus 2? By backward substitution find the formula, wherever n is present replace it with by n minus 2. Okay, again 2 square, what is m of n minus 2? Substitute the value, that is 2m n minus 3 plus 1 plus 3. Again 2 square is 4 plus 2 square is 4 plus 3, that is 7. Okay, next again find what is m of n minus 3, substitute the value. Consider first the 3 sum, that is 2 to the power 4 m of n minus 1. How can we write this 15? That is 15 write as 2 cube plus 2 square plus 2 plus 1, right? Correct, right? Hence in the ith substitution, 2 to the power I m of n minus I plus 2 to the power I minus 1 I minus 2 plus 2 plus 1, like this way it goes on. Hence the general formula we find what? 2 to the power I m of n minus I plus 2 to the power I minus 1. We substitute for this, that is 2 to the power I minus 1. In the initial condition what we take, n as 1, that is replace I by n minus 1. M of n becomes, wherever I is there replace it by n minus 1 times we are moving, right? 2 to the power n minus 1 m n minus 1 plus 2 to the power n minus 1 minus 1. Okay, that is nothing but 2 to the power n minus 1. So solve this, plus n minus n cancels, m of 1 plus 2 to the power n minus 1 minus 1. What is m of n? 1 is nothing but 1, 2 to the power n minus 1 plus 2 to the power n minus 1 minus 1, that is nothing but 2 to the power n minus 1, which is belong to order of 2 to the power n. The third problem is about to find the number of a binary algorithm in the binary representation on the positive decimal integer. Algorithm is a binary recursion of n. Input is a positive decimal integer n. Output is the number of binary digits in the n's representation. Let's see the algorithm. If n equal to 1, return 1, else return binary recursion of floor division of n by 2 plus 1. Okay, let's see this algorithm by an example. Consider if n equal to 1, we have to return what? 1. Okay, consider if n equal to 3, whether it is n equal to 3, condition false, go to else condition, else return a binary recursion of n by 2 plus 1. What is the value of n is nothing but 3, that is 3 into 3 by 2 plus 1. 3 into 3 by 2 floor division we have to do, remove the point, that is 1 plus 1. Can you say what is b of 1? In the previous value we are doing what? A recursive algorithm. B of 1 is 1, 1 plus 1 is 2. Consider if n is 10, whether it is equal to 1? No. Go to else condition. Next, return binary recursion of 10 by 2 plus 1. Again do floor division, binary division, binary recursion of 5 plus 1. What is we got b of 5 plus 1. Again check the condition whether 5 is equal to 1. No. Again move to else condition. 5 by 2 plus 1, that is 2 plus 1. Again whether 2 is equal to 1. No. Again go to else condition, return binary recursion of 2 by 2 plus 1, that is b of 1 plus 1, that is 2. Okay, let's see mathematical analysis. What is the input size? A given number equal to n. Basic operation we performed is addition. No best case, worst case or average case. Let a of n denote the number of addition we performed. A of n is nothing but a of n plus 2 plus 1 for all a or n equal to, for all n greater than equal to 1. In the initial condition, set a of 1 is 0. Okay, where a of n by 2 is to compute binary recursion n by 2 and 1 is to increase the returned value by 1. We have to note why n 1 is used to increase the returned value by 1. Next, see the recurrence backward substitution. A of n, the formula we have. Assume, let's say, n as 2 to the power n by smoothness rules. Then substitute 2 to the power k. N as 2 to the power k. A 2 to the power k divide by 2, that is 2 to the power k minus 1 plus 1 for all k greater than equal to 0. What is the initial condition? A2 to the power 0 becomes 0. We have the formula for a2 to the power k equal to a2 to the power k minus 1 plus 1. A substitute, we have to find what is a2 to the power k minus 1. We have now formula, substitute k by k minus 1. K minus 1 minus 1 becomes k minus 2 plus 1. Again substitute for a k minus 2, that is a of k minus 3 plus 1. Okay, substitute a 2 to the power k minus 1 by 2 to the power k minus 2 plus 1 plus 1, that is plus 2. Again substitute a 2 to the power k minus 2 by a 2 to the power k minus 3 plus 1 plus 2, add 3. In the ith recursion, find the general formula, that is a 2 to the power k, it is increment by 1 minus I plus I. Whenever I is k, substitute I by k, a 2 to the power k minus k plus k, that is a of 2 to the power 0 plus k, where we know initial condition a 2 to the power 0 is 0, 0 plus k, that is k. We know that n equal to 2 to the power k, then k becomes log of n, right? A of n becomes log of 2, hence it belongs to order of growth is theta of log n. So this is 3 problems about recursive algorithm If you understand, then please like the video and don't forget to subscribe my channel. Thank you.